last topic in stoichiometry is percent yield. And percent yield, the actual yield over the theoretical yield. Actual yield is what you really make in the experiment if you do it in the lab. And it has to be a product. Theoretical yield is what you're going to calculate. So if we look at this problem, you're given 13.1 grams of calcium oxide. We're also given 24.8 grams of calcium carbonate. One of those is the actual yield. Well, that's easy. The actual yield is 13.1 grams of calcium oxide because calcium oxide is a product. And also, the problem said is produced. So we know that ultimately, what is the percent yield? We're going to be finding percent yield, which is going to be 13.1 grams of calcium oxide divided by some grams of calcium oxide that we calculate, and then we're going to multiply this by 100. So we know we have to calculate grams of calcium oxide. So even though we have carbon dioxide as a product, that's not the product that we're interested in. So we're going to start with our 24.8 grams of calcium carbonate. I'm going to put grams of calcium carbonate on the bottom. Moles of calcium carbonate on the top. And then moles of calcium carbonate are going to come to the bottom. Moles of calcium oxide to the top. Moles of calcium oxide to the bottom. And grams of calcium oxide to the top. So this is just our typical mass to mass problem. Here's our molar mass step, our mole ratio, which uses the coefficients, and another molar mass step. So when grams and moles are together, moles gets 1, grams gets the molar mass. 40.08 for calcium, 12.01 for carbon, 48 for 3 oxygens, 100.09. Coefficients are 1 and 1. Calcium oxide, well, I can just subtract the 48 oxygens away from that. You get 52.09. That's wrong. Let's scratch that and start from scratch. 40.08 for calcium plus 16 for an oxygen. There we go. 56.08. And that is 1 mole. So 24.8 divided by 100.09 times 56.08, 13.9. So we made 13.1 grams out of a theoretical 13.9. So 13.1 divided by 13.9 times 100 gives us 94.2%.